In section 2.2, we get away from what we were calling the limit process of finding the derivative, and we just start finding the derivative, which is really nice because that means you don't have to go through the whole headache of using f of x plus delta x minus f of x all divided by delta x. What I want to do is go over some of these problems that we've done from the previous section, so go back in your notes and find some problems that we took the derivative of. We'll write them down, the original and also f prime. Give me one of them. X cubed plus 2x. And what was the derivative? Okay, give me another one. 2x squared. And what did we get?
2x squared
minus 5. Okay. Two x cubed minus 5x plus 1. What did we get? Okay, give me another one. 3x squared plus x. What do we get? Six x plus 1. More. Okay, not that one. Stick with polynomials. X plus 1. And we get? We did do one that was a line. Was it 2x or? Two x, and what do we get? Okay, well if we did 2x, we'd get 2. We have any others? X squared plus 1 gives us? Holy cow. If we had x squared plus 1, what would we get? We would get 2x. There clearly is something going on here. There is a shortcut to the limit process. Look at these problems here and see if you can see it. What about powers? What happens? The degree of the polynomial is 1 less. What happens to the exponent? Do you guys see it? What about on this one? Okay. What happened to this? What was the degree on that term? What did it become? 0. What's x to the 0? 1. What was that coefficient in front of it? What's 1 times 1? Take a look at this one. 2x to the third turned into minus 5x turned into. And what happened to that plus 1? It disappeared? It's what? Just disappeared. Did that happen down here for the x squared plus 1 as well? Okay, can we come up with a rule maybe? Like a rule would be if I have f of x equals something to the nth power, then f prime of x would be okay, this guy comes down, nx to the n minus 1. Is that what you guys are doing? There you go. Let me draw a little sketch on here. If I drew just y equals 3, and I wanted to take the derivative of that, I'd be finding the slope of the line y equals 3, which happens to be a horizontal line with a slope of 0. So if I take the derivative of a constant, I get 0, like number 1 on your quiz. Okay? So, now that we know that, here are your basic rules for differentiation. This is a very formal format here, but I am also giving you some examples. What we have is the constant rule. That's what I was just talking about. If you take the derivative of just some number, that's like taking the derivative of y equals that number, which is a horizontal line with a slope of 0. So therefore, the derivative of a number must just be 0. For example, if y equals 3, then y prime equals what? 0. Because the slope of that line was 0. That's the constant rule. The power rule is the one that you just developed. If I take the derivative of a variable to an exponent, x to the nth power, then the exponent comes down times the variable x, and then you, what I say is decay the exponent by 1. So the n comes down times the variable, decay the exponent by 1. So for example, if I have y equals x squared, then y prime would be what? The 2 comes down times the variable, decay the exponent by 1. 2 minus 1 is 1, so technically it's 2x to the first, but we don't write the 1, so we just leave it 2x. That was the power rule. The constant multiple rule is very similar to the power rule. You also already developed that one. If I take the derivative of now not just x to the n, but some number times x to the n still comes down, but now it multiplies times that number that was out front, times that coefficient out front. We still decay the exponent by 1. So for example, if y equals 3x squared, then y prime would be 6, because 2 times 3 is 6, x to the first, and I don't write to the first, so I just have 6x. Those three rules combine to make the fourth rule, the sum and difference rules. Basically what this says is if I have a whole string of terms, I can take the derivative of each individual term using these properties right here. So if I have, this would be one term plus another term, then that would be the derivative of that first term plus the derivative of that second term. It's just like adding limits together, yeah. So if I have y equals 5x to the third minus 4x, then y prime would be what? 15 x squared minus 4. The derivative of negative 4x is negative 4. That's negative 4x to the first. You take the 1 down. 1 times negative 4 is negative 4. This becomes x to the 0. X to the 0 is just 1. Negative 4 times 1 is negative 4. These rules can be repeated for every single term in an equation as many times as is necessary to complete the derivative. Don't have to do limits anymore until it comes time to take the AP exam. So we just have some practice problems here. Find the derivative of f of x equals 1/3 x to the third minus 4x squared plus x plus 6. How many of you would like to do that using the limit process? No. Probably not. That would take a long time. So let's just go f prime of x equals, no, the 3 comes down, right? And I have 3 times 1/3, which is 1, x to the second, minus, the exponent comes down, minus 8x to the first, I don't have to write that, plus 1 from this guy, and then that 6 goes away. So that is the derivative right there. Yeah. Now you can do calculus in your head. Okay, find the derivative of these three things. First one, fairly easy, right? F prime of x equals 5x to the fourth. Using the limit process on that one, you'd wind up using Pascal's triangle with the fifth row, right? I don't even know off the top of my head. Or you could use permutations and combinations in the binomial theorem. No? How about you just use the shortcut? Way easier. Okay, for these next two problems, we have to rewrite this. If I rewrite this, it becomes f of x equals x to the negative third power. And now you can just take that derivative using the same rules that we're talking about. F prime of x equals, the exponent comes down, negative 3 x to the, now, what do we do to the exponents? We're subtracting 1 from the exponent. So it becomes negative 4. So be careful about that. Make sure you're understanding that we're subtracting here. Now I need to rewrite that back because I can't have answers with negative exponents. So this becomes f prime of x equals, the negative 3 stays on top over x to the positive fourth on the bottom. That's your answer. The key here is rewrite. We can also rewrite this third problem sitting here. Becomes x to the 1/3 power. Good. And now we can use that same property. So we get f prime of x equals, go slowly, the 1/3 comes down, x to the negative 2/3. We can't have a negative exponent in our answer, so we will rewrite this. F prime of x equals, that 1 is on top, the 3 is on the bottom, the x to the 2/3 also goes on the bottom. And we're going to leave our answer just like that. We don't have to worry about rationalizing or any of the other junk. That is the answer. Okay, so in general, you may need to rewrite the equation to make finding the derivative easier, especially if you're dealing with root functions or rational functions. So if I give you y equals 1 over x squared, you would want to rewrite that as y equals what? X to the negative 2. If I give you y equals the square root of x, you'll want to rewrite that as y equals x to the 1/2. And if I give you y equals the fifth root of x to the fourth, you would want to rewrite that as x to the 4/5. That's right. Okay? See if you can take those three derivatives now. The derivative of y equals 1 over x squared becomes x to the negative second, which means y prime equals negative 2 x to the negative third, and I got to rewrite that. Y prime equals negative 2 over x to the third. So that would be my answer. We rewrite this one as x to the 1/2, and y prime then would be what? 1/2 x to the negative 1/2. Do that first, then rewrite it. Y prime equals x to the 1/2. And you could see your answer like that. You could, since this is just square root really, you could rewrite that as 1 over 2 square root x. Either one is going to be fine, just depending on what the problem is asking to do, or if maybe it's a multiple choice problem or something like that, they might go back to the square root format. This one, on the other hand, becomes x to the 4/5, which means y prime will be what? 4/5 comes down, x to the, we take 1 away from 4/5 and we get negative 1/5. So I got to rewrite that. Y equals 5x to the 1/5. And I would leave my answer like that. I don't want to mess with nth roots too much. All right, here's my helpful hints for success when you're taking derivatives. First of all, rewrite the function if necessary. Second, the usual rules for answers still apply. These guys, no negative exponents. Leave your answers in rational exponent form. You don't need to switch to root notation. You don't need to rationalize. You can leave roots in the denominator. You can leave rational exponents in the denominator. You just can't have a negative exponent for an answer. This third one right here is key. Watch for fancy ones and other ways to simplify the answer. As we get going deeper into this chapter, and for really the rest of the year, there's going to be lots of times where things sort of start dividing out and reduce down. You still have to watch for that stuff. All right, find the derivative of each function. What do I need to do with my first problem here? Rewrite it. So this becomes 2x to the negative first power. And now I can take the derivative, and I get y prime equals negative 2 x to the negative 2 power. Rewrite it. My answer would be y prime equals negative 2 over x squared. Okay. Over to the right. What do I need to do here? Did you just assume something?
No.
You can rewrite this because some people will get confused when they see this format. This is actually just 4/5 times x squared, right? Okay, and now hopefully you can see that you can just use the power rule. We get y prime equals what? Yeah, 2 times 4/5 is 8/5. X to the first power, so that's it. That's the answer. It was actually kind of an easy problem. The third one, y equals 2 root x. Rewrite it. What do you get? 2x to the 1/2. So now we can take the derivative. Y prime equals 1/2 times 2 is 1, so we wind up with x to the negative 1/2. So y prime equals 1 over x to the 1/2, which is the square root of x. I'm going to, since that's so easy to write, I'm going to write it like that. The last one, I screwed up. I should have a y equals there. And we should rewrite that. How do I rewrite something that looks like that? One half, I like. X to the negative 2/3. Okay. Y prime equals negative. So you have 2/3 times 1/2, which is 2/6, which reduces to 1/3. X to the negative 5/3. So y prime equals negative 1 over 3x to the 5/3. That's right. I want to say one thing here before we call it quits for today. If you are the sort who writes their fractions like this, you need to stop immediately. You need to write them over each other. We're going to be working with fractions so much in this class, rational functions, rational exponents, and things like that, that if you are writing like this, I guarantee you will make mistakes because of the way that you're writing this down. Switch to this, okay? No more of that. I don't know if that's anybody in here, but just in general, okay?